is my quantum gravity video 13, and I'm recapitulate something first. Uh, in this video, I intend to go on the topic of unification of the four forces of nature, which were, in fact were already mentioned in my previous videos, video 5, 6, 1, 2, 3, 4, 5, 6. But because they are so scattered, I want to, in this video, in one video, to try to elaborate on the subject. First, I have Newton's law of the force is equal to G, gravitational constant, times the mass of two objects separated by distance r, which will be F is equal to G m1 m2 divided by r square. And secondly, we have the electromagnetic force, which is under the Coulomb's law. Force is equal to charge Q1 and Q2 divided by the 4 pi epsilon naught. Epsilon naught is 8.854 times 10 to the power minus 12 Farad per meter, and by r square. And then from my video 1, I already have found a relationship between Q square is equal to 10 to the power 7 times the mass times the radius or the wavelength. That's the distance between the two masses, or from the mass to the point of pivot, the pivot point, and which in order to be equal, they must also be multiplied by a constant, the fine structure constant alpha. That is. Unit-wise is already Q square is Coulomb square. Mass is in kilograms, and R is in kilometers. The SI unit is used. That's the kilogram meter second unit. The alpha here is the fine structure constant, and it's either 1 over 137.036 or 72.297 times 10 to the power minus 3, which is a dimensionless constant. For my video 2, I have already deduced the relationship of h bar, which is the reduced Planck constant h divided by 2 pi, and this h bar is equal to the mass times radius times mass times radius times c. C is the speed of light in vacuum. So have equation 1 here. Q squared is equal to 10 to the power minus 7, 10 to the power 7 times mass times radius times alpha, the fine structure constant. Equation 1. Equation 2, h bar is equal to m times the mass times radius or wavelength times the c, the speed of light in vacuum. And then this relationship from my video 1 and 2, I have deduced that this relationship, both unit-wise and numerical mass. They should be equal. And they are equal for all masses m, all lengths r, or radius, or wavelength, which satisfy 2, the equation 2. For all masses or particles which satisfy equation 2, this relationship 1 holds. And one more thing, the Q must be the elementary charge, that is 1.602 times 10 to the power minus 19 coulomb. And this is the Q squared to 10 to the power 7 m mass times radius or wavelength times alpha is my equation 3 here. For example, so that this equation works. For example, for electrons, Q squared is equal to 1.607602 times 10 to the power minus 19 whole square, coulomb square, that is the unit. Mass is equal to m is equal to 9.109 times 10 to the power minus 51 kilogram. This is for electron. And then the radius is the Compton wavelength. The Compton wavelength is usually given by this 3.86 times 10 to the power minus 13 times 2 pi. But now I have to separate it out and divide it by 2 pi. So it is I take the radius. This is actually the radius of the wavelength of the electrons. It's 3.86 times 10 to the power minus 13. And alpha is equal to 7.297 times 10 to the power minus 3. And that is Q squared is equal to 2.566 times 10 to the power 38. This is Q squared. This is Q squared. The value of Q squared. And this one is equal to 9.109 times 10 to the power minus 31 kilogram times 3.86 times 10 to the power minus 13 meter. This is the Compton wavelength divided by 2 pi. And times 7.297 times 10 to the power minus 3 and times 10 to the power 7. This is actually my equation 3 here. We have the 10 to the power 7 mass times the radius times alpha. And likewise, this equation works for protons with Q squared is equal to 2.566 times 10 to the power minus 38. This molecular value is equal to 1.673. This is the mass of the proton times 10 to the power minus 27. And times 0.21 times 10 to the power minus 15. This is the proton usually reputed proton radius or proton wavelength times 7.297 times 10 to the power minus 3. This is the fine structure constant alpha. Likewise, it also applies for all other particles. For example, the top quark. I think just name one example. I cannot all the many examples here. You have Q squared is equal to 2.566 times 10 to the power minus 38 is equal to 3.17 times 10 to the power minus 25 kilogram. This is the mass of the top quark in joules. Times 1.11 times 10 to the power minus 18 meter. This is the wavelength or the radius of the top quark times 7.297 as usual. This is the fine structure constant alpha times 10 to the power 7. Just to show that this equation here is works for equation 3 works for all particles. Substitute equation 3 in Coulomb's law. Then you note that 1 over 4 pi times 10 to the power minus 7 is equal to C square is equal to C square. This is electromagnetic identity. We have F. This is Newton's law. This is not Newton's. This is Coulomb's law. F is equal to m times c square divided by r. This is 6. Let's see. I have skipped some part here. From video 2, sorry, I skip a part. From video 2, I have already mentioned that G in my quantum gravity series video 2. G, the Newton's gravity constant, is equal to 1.616 times 10 to the power minus 25 meter. This is the Planck's length. Divided by 2.177 times 10 to the power minus 8 is the Planck mass times c square. That's the light speed square, 3 times 10 to the power 8 all square. And this is about 6.6975 times 10 to the power minus 11 Newton meter square per kilogram square. This is my equation 4. As equation 3 works for all particles, the masses and radius, as wavelength, of which are known. It also works for Planck mass and Planck length. And Q square is good. This is I just use this my former equation 3 to work once again for Planck mass and Planck length. Q square is equal to 10 to the power 7 times 2.177 times 10 to the power 8 is Planck mass times 1.616 times 10 to the power minus 35 this meter. This is the Planck length, and multiplied by 7.297 times 10 to the power minus 3 is the fine structure constant. I just used my equation 3 above for Planck mass and Planck length. It shows that it also works for Planck mass and Planck length. And now a substitute equation 4, that is for G, is equal to Planck length divided by Planck mass times c square. Now I substitute it in Newton's law. F is equal to M1 and M2, doesn't matter. Either M1 or M2 times c square divided by R. The important thing is the force is simply equal to one of the masses. If you have two objects, you find the force between them. This is either mass times the c square divided by the r, the distance between them. Now we substitute the equation 3 in Coulomb's law. I have already done that for Newton's law. Now I substitute for Coulomb's law, and look that you have to look at 1 divided by 4 times 4 pi times 10 to the power minus 7 times epsilon naught 8.854 times 10 to the minus 12 Farad per meter is equal to c square. Then what do we have? You have F is equal to, again, m times c squared divided by r. The final result. This is equation, I call it equation 6. And this proves that the force of gravity under the Newton's law is identical with the electromagnetic force under the Coulomb's law. What makes one of these forces look different from another is therefore just the magnitude of m, the mass in the numerator, and or the magnitude of r in the denominator of equation 5 and 6. What makes an electromagnetic force looks different from the gravity is just because the magnitude of m may be bigger, much bigger, or maybe the distance between much bigger or much smaller. This will make them either look different, the two forces. For example, to account for to explain the difference in the magnitude between a strong nuclear force and the gravitational force. This difference is usually said to be 10 to the power 39 as a huge sum. We note that under the Glasgow-Winburn-Salem model, the weak force has already been predicted to be identical with the electromagnetic force, in that these two forces merge into one above the unification energy of 246 bigger electron volts, that is equivalent to 3.941 times 10 to the power minus 8 joules, or 4.379 times 10 to the power minus 25 kilograms. And in video 6 of my quantum gravity series, I have already demonstrated that the electromagnetic force under the Coulomb's law without the wavelength of radius in the denominator set to that of the proton radius or wavelength is just equal to the strong nuclear energy potential or force, which is also computed at the same wavelength or radius. To compare the nuclear strong force and gravity, we utilize this equation. E, where ER or the P in the equation, in the expression, or in the equation 7, you have P and cosine theta, and then in the equation 8, you have the M in the cosine theta, and ER represent the electric field, BR represent the magnetic field, and P represent the electric dipole moment, M represent the magnetic dipole moment. This and the angle, the theta is angle between the direction of the in consideration the direction in which the dipole moment or the electric field act with R, the direction of where we have to consider the force. Because you have a force, if the force acting this way, then if you consider the object, the component of a force acting in that direction, then you have to consider the angle between the two, the electric field or the electric dipole moment and the direction of in which the component of that force on the object at an angle theta. That's where the angle theta comes in. This source of this equation, I got it from the page 138 of the Cambridge Handbook Physics formula of Mr. Graham Wong. These equations are, you have to look, of course, at the electromagnetic equations. However, as I've already demonstrated, proof that the electromagnetic force and the gravity are identical. Thus, this equation must also apply here. For the comparison of the not only of the electromagnetic force with gravity, but also with the strong nuclear force with gravity, because I've already in my video 6 demonstrated that where electromagnetic force are set to the same distance or wavelength or radius as the strong nuclear force. If they are set to the same, then they are actually identical, equal, and identical in any other respect. Now to compare the magnitudes of the strong force and gravity, set P cosine theta to be unchanged, and pi and epsilon naught, of course, they are constants. Now set R to 0.21 times 10 to the power minus 15. This is the reputed wavelength radius of the proton. Then we have P cosine theta, 2 pi epsilon naught is a constant, and divided by 0.21 times 10 to the power minus 15 meter to the power 3. So you got P cosine theta divided by 2 pi epsilon naught, 9.26 times 10 to the power minus 48. 10 to the power 15 times 3, 0.21, all to the power 3. So you got 9.26 times 10 to the power minus 48. Set R to 10 to the minus 3. What's 10 to the minus 3? Is 1 millimeter. 1 millimeter. This is the smallest distance when we consider two objects. We usually consider when we consider two objects, the gravity between them. They cannot be smaller than this amount. That's 1 millimeter. Otherwise, the two objects usually cannot. When we are considering gravity, they cannot merge. They cannot merge into another. The smaller distance is about 1 millimeter. So we got P cosine theta 2 pi epsilon naught times 10 to the power minus 3 to all to the power 3 is equal to P cosine theta 2 pi epsilon naught 10 to the power 9. 10 to the power 9 divided by 10 to the power 9. So all these P cosine theta are considered to be the same, but we only consider the distance now. The only distance, the difference is only in distance. One is 10 to the power 9 minus 9. One is 9.26 times 10 to the power minus 48. So that compare the two results, the strong nuclear force is therefore 10 to the power 39 times of the gravity. You can use the same method to deal with the magnetic field and the magnetic dipole moment, just to compare the distance between them, and then use the same results. So I think I'll stop here for this topic. This is unification of the gravity with electromagnetism, and also to explain the difference of 10 to the power 39 between the strong nuclear force and the gravity. So I stop here. I'm man child or Canada child, you can as you like. So